Alright, welcome to the third week of NTI and the fundamental theorem of calculus. So this is the first fundamental theorem of calculus that we'll see. The FTC is what we'll call it, and it says that a function f of x, if that function and its integral, capital F of x, are defined on a closed interval, so they have y values, and that interval is a to b, then we can evaluate the integral like so. We can take the integral of the original function from a to b, which we know the notation to be capital F of x. And we'll use a symbol here to show we're going to input a and b into capital F of x to evaluate capital F of b, and then we're going to subtract capital F of a. This is going to define the integral operation, which is what we were doing with the indefinite integral. So now we have a definite integral from a to b that we'll be evaluating using this method here. So for our first example, we'll take on just x squared. Pretty standard. The integral should give us the area between the curve x squared and the x-axis between 1 and 2, between x values 1 and 2. So what we'll do first is we'll actually, I'll leave this up here, we'll actually integrate x squared. So I have capital F of x equals 1/3 x cubed. And instead of writing plus c, we're going to evaluate this at 1 and 2. So I'll perform the operation with 2 cubed, because that's what would happen if I were to put 2 into my x variable. And then, so let me highlight that, 2, and then I'll subtract the integral function evaluated at 1. So this operation will give me the area between the curve x squared and the x values 2 and 1. So if I carry this out, I'll have, this is just a little calculation, 1/3 times 8 minus 1/3. So I'll have, what is that? 8/3 minus 1/3. So that would be my final answer. So for these next examples, what I recommend is write this down and see if you can't evaluate these examples as I go, or by pausing the video and then trying it for yourself. So I'm going to get into this one. The integral function is x cubed minus x squared. So I'm using the inverse power rule, and then I'm subtracting x, and then I want to evaluate this, and you might see a bracket written here to just show you're evaluating from -1 to 3, or you might just see a bar showing that you're evaluating capital F of 3 minus capital F of -1. So that's what I'll do. I'll say 3 cubed minus 3 squared minus 3, and then I have to subtract the new evaluated function, the new evaluated integral at -1. So I'll put in -1, cube it, -1, whoops, minus -1 squared, right? Because that's what the function says to do, and then minus -1. So here you can see that every time I put in a 3, that's capital F of 3, and of course the other one is capital F of -1. And I'm making sure to subtract the entire function. So I've got these large brackets around what I'm subtracting. So the problem for us is usually going to be algebra here in this case. We already know from a calculus standpoint this should end up as the area under the curve between -1 and 3 and the quadratic. So the accumulated area. We just have to make sure we get all this algebra right. Yay! So this means the area between -1 and 3, so I'm using interval notation, the function, which is the 3x squared minus 2x minus 1, and the x-axis. Great. Okay, so here are a couple other examples I'm just going to fly through just to refresh your memory on how to integrate something that looks like this, how to rewrite the function. So first thing I have to do is rewrite this one to be a little bit nicer. So this is 2/3. I'm writing it so I can use the inverse power rule. And now I can maybe put that into my calculator or evaluate it by hand. So when you're figuring your answers, make sure you're being careful and you're checking your work. The last example I've got for us is one that requires a little bit of manipulation. So we'll manipulate this to look like we're going to use the inverse power rule. So here the trick is to rewrite what we're integrating to be x minus 2 times x to the -1/3. So here I've got it rewritten, and my problem is still not really simple, because I still have to take care of distributing this x to the negative 1/3 to each term. So I'm going to do that because remember, it's not a good thing to integrate unless it looks like the inverse power rule. So how do I deal with this? I've got x times x to the negative 1/3. So I'll add their powers. So I get x to the 2/3, and then I have minus 2x to the negative 1/3. And now I can integrate these things. And again, we're not adding c because it's not. This is a very specific area. It's not a generic equation of an integral anymore. And we'll see how those two mesh together later on. So that's our final answer here. What I would make sure you have is enough space. Make sure you're working down. I know at the very beginning I wasn't working down to just show the chain of events from just the definite integral definition, or using the fundamental theorem of calculus. So make sure you're completing each step. It's going to be pretty helpful to know what you have. So I've used a lot of notation to show that I'm evaluating f of 3, and here is where I'm evaluating f of 3. I'm doing it right here, and I'm showing all the steps. So just be careful with that, and in the coming weeks we'll combine what we know about these definite integrals and the fundamental theorem of calculus with what we've learned already with u substitution and indefinite integrals.